In this video, we're going to be using the angle-side-angle congruence theorem to prove triangles are congruent. Remember, this theorem states that if you have two congruent pairs of angles in two triangles and a congruent pair of sides, and this side is in between the two angles. So notice in our picture here, the side is in between, or it's called included. It's the included side of the two angles. Then you are using the angle-side-angle theorem, and you know the triangles are congruent. So we're going to be heading to our proof workbook, the angle-side-angle proof number 1 on page 5. In this proof, they tell us line segment QR bisects angle PQS. So let's go ahead and let's add this into our 2-column proof. Now we need to remember what it means for a line segment to bisect an angle. This goes all the way back to chapter 1. Line segment QR bisects angle PQS. So this angle here. Remember, to bisect means to cut the angle into two equal pieces. Well, if line segment QR bisects angle PSQ, this angle here, angle PQR, must be equal or congruent to angle SRQ. Angle PQR must be congruent to angle SQR. These two angles have to be congruent, and that is the definition of an angle bisector. And so this first given statement, that helped us get a pair of angles in the two triangles that were congruent. Don't forget our other given. They also tell us that angle PRQ is congruent to angle SRQ. And that's just something that's given to us. Angle PRQ, that's this angle here, is congruent to angle SRQ. So there is another pair of congruent angles. So now we're trying to find any other sides or angles that could possibly be congruent in these two triangles. I notice that the two triangles share a side. They share side QR. So it must be congruent to itself. Line segment QR must be congruent to line segment QR. They share that side. That is the reflexive property. So we can see in our picture, we have one pair of congruent angles, two pairs of congruent angles, and the included side is congruent. That is an angle-side-angle theorem. We can now say that the two triangles are congruent by the angle side angle congruence theorem. Sorry, I was looking at the wrong order. Angle side angle. All right, let's go ahead and do the last angle side angle proof on page 6. Okay. Our first given, line segment AC bisects angle BAD. Line segment AC bisects angle BAD. That is this angle here. So just like we discussed in the last proof, if it bisects that angle, it cuts it into two congruent pieces. So using our first given statement, we know that angle BAC has to be congruent to angle DAC by the definition of an angle bisector. So if you are given an angle bisector in a problem or in a proof, you're going to be using that to find two congruent angles. All right, we are also told that line segment AC bisects angle BCD. So it also bisects angle BCD. It cuts it in half into two equal pieces. So again, this angle must be congruent to that angle. So let's name those. Angle BCA must be congruent to angle DCA by the definition of angle bisector. So right now I've got two pairs of congruent angles in my picture. I just need one more congruent part. Again, I notice these two triangles share a side. They share line segment AC. So line segment AC has to be congruent to itself. Line segment AC has to be congruent to line segment AC by the reflexive property. So looking at the picture, we have an angle, side, angle congruence theorem in that order. The side is in between the angles. So now we are able to state that triangle BAC is congruent to triangle DAC by the angle, side, angle congruence theorem.